Sensors bring real-world data into the Internet of Things. Superheroes are more than handsome men and women running around wearing capes. They can see and hear just about anything. As in Spider-Man's Spidey senses, superheroes seem to detect the undetectable. The Internet of Things will be a superhero among our time, for it brings innovation and efficiency like never before. IoT can perform computations and make predictions far beyond normal human capabilities. Like all superheroes, IoT has its limitations, in that it must first have high-quality information to act upon. And this is where sensors become the superhero. Sensors are not only the eyes and ears of IoT. There's a large range of other information that these devices can detect. Sensors detect and describe some type of input from the physical environment and then transfer that information in a one-way direction to be analyzed. It is crucial to realize the effectiveness of a superhero, and similarly the Internet of Things, is based on how often and how valid the original information is. For example, what good are Aquaman's underwater abilities if he doesn't have sonar to see the underwater world around him? Sensors are important and unique to each situation. There are hundreds of sensors that can collect a wide variety of data points. Sensors can be broken down into several types based on their intended purpose. And within each type, there are different classifications to be aware of. There are several types of sensors: acoustic, optical, chemical, environmental, automotive, along with many others. Acoustic sensors can detect and measure sound waves. One such example is an ultrasonic sensor, which uses ultrasonic sound waves much like bats do with their application of echolocation. Optic sensors can detect and measure light, along with the rest of the entirety of the electromagnetic spectrum. These sensors can see the world with the same color and detail as the human eye, but they can also see frequencies above and below those of the human eye, thereby giving the sensors their superhero powers. Sensors can detect a wide range of previously invisible light, ranging from the heat radiating from an animal's eye to the inner bone structure of a hand, all the way out to gamma ray bursts from a distant nebula. Chemical sensors can detect and measure the chemical composition present within a given sample. These samples can be a solid, liquid, or a gas, and their chemical detection possibilities can range from analyzing the impurities in the air with a smoke detector, to determining the water quality in our oceans, to quantifying the soil composition in a farmer's field. Environmental sensors can detect and measure various conditions within the atmosphere. These sensors are normally found within a typical weather station, but IoT will be able to collect this valuable information anywhere at any time with a high degree of accuracy and a low degree of latency. Automobile sensors are as they sound. They can detect and measure various conditions within automobiles and all other forms of transportation as well, including planes and trains. This allows for real-time data and positioning to be collected for internal and external analysis. Again, there are numerous other sensors used for a gambit of data collection applications. Once a sensor is chosen based on the information required, it is also important to consider the classifications of a sensor. Sensors are classified by sensitivity, resolution, latency, and energy requirements. Sensitivity is determined by a sensor's ability to perceive a change in a characteristic. Sensors that have a high light sensitivity would be able to distinguish a red from a pink, or slight changes in a light's intensities, whereas a low light sensitivity may only need to know black from white or light from dark. Resolution. Resolution is determined by the number of data points a sensor can collect within a given event or data capture. Photography and video game imagery are great examples of how resolution has increased over the years. From the pixelated images of the past to the high definition clarity of today. Latency is determined by the frequency of the data collection events. For example, the latency in the sensors of a self-driving car must be in milliseconds. But in the case of watching wildlife at night, longer time intervals can be set. The latency of a sensor is directly related to its efficiency, implying data collection is crucial, but too much or redundant information is a waste of resources. Which brings us to energy requirements. The energy required by a sensor is determined by its size and capability. Energy is required for every operation, and therefore, the more operations, the more energy. So with an increase in sensitivity, resolution, and/or latency, the greater the energy needs. Energy will need to be supplied by batteries, which can be large and bulky, or by an external supply. But then the sensors will need to be hardwired to the source, which will restrict its mobility and lessen the usefulness of IoT.